All right, let's proceed to section 3 of this series. And what we have so far, in fact, how about we just run the application so we know exactly what we have. On the last two sections, what we did is build a user interface like so, and the idea is we wanted to have the ability to upload a CSV, and in this case, we're using the iris dataset, and we should be able to populate these three tabs here. And in the last section, we worked on populating the raw data tab, and if and we use the render data table, in fact, to get us this kind of display. And we said right off the bat, you have the ability to make a few filters here and see the data being displayed, which is very powerful. What we're going to do now is we're going to make sure that we, first of all, add a few selection criterias here. So add a few sidebar menus for the selections we need to build basically a scatter plot on top here, and probably a correlation heat map at the bottom, and also the distribution plot, depending on how far we get through this session. So let's go ahead and, yeah, let's just go ahead and start coding this thing. So yeah, so underneath the raw data, where we're rendering the raw data, let's go ahead and create our what we call a correlation menu item here. So this is going to be an output ID as well, and it's going to be correlation filters, and this is going to take the render menu function like so. And remember, whenever we have these functions, we can simply use the parentheses to make sure that that's where all of our code is going to go in there. So what we want to do, remember, the objective is to generate a scatter plot, and that scatter plot would be responsive to the sort of the selections from the user. So we need to create a sidebar menu that allows us to select sort of an X and a Y metric, and probably the species as well, so that we can render that relationship the way we see fit. And if that doesn't make sense right now, that's fine. It will make sense once we begin to render some of these things as we go on. So the first thing we're going to use is almost the same thing we've used above. Is if we have the data, right? If we have the data, we want to render this sidebar menu. If we don't have the data, then don't render it at all. So we're going to go with is null, and we know that we have made sure that our data object is data. In fact, before I forget, let's see if increasing the font here, maybe that's a little bit too much. If increasing, so because I've seen in some of the previous videos that the font might have not been high enough. So let's try 13, apply 13. Okay, so maybe that will be bigger. I will check after the fact. It looks bigger on my screen, so that's why I will check after the fact. But if this is null, right, we don't want to render any kind of sidebar menu, right? We want only to populate the second sidebar if there is in fact data that has been uploaded. And so else, right, if in fact that's the case, then we can start to play around with this thing. So the first thing we're going to do is we want to make sure that we get a only numeric data frame. So I'm going to say here the numeric data frame variable. What I mean by only getting the numeric data frame is to only separate the columns that have numeric data type from the species column, which is categorical. And the way we do that is I'm just going to make sure that I convert it as a data frame just in case. It is going to be a data frame, but just in case, I'm going to do this as data frame. And then from there, I'm going to use the sapply function, like so. So I'm going to say sapply, and we're going to apply this on the data. And the function we want to apply here is to check if this is numeric. Now, if this is the first time, if you're not comfortable with R, maybe, yeah, let me just write it perhaps in a better way, and not because I know this is a data frame, maybe this is not the best way to approach it. So what we're going to do is we're going to say data, right? Calling the data frame here. In fact, let's not even do it that way. Let's start with the sapply. I think it'll make sense why this syntax below here sort of is a resulting factor. So sapply is going to take our data frame, like so, and it's going to evaluate if, you know, what rows are numeric and what columns are numeric and which are not. Okay, it's going to evaluate everything. Right, so it's basically going to give us some trues and some false. And what we want is to return all the trues. And the way we do that is we just add these brackets, and on top of that, add the data frame itself. Okay, and then from here we can pass this into the numeric df, the variable I was talking about earlier. So this is very much what I wrote here before, except I just want to make sure that this object here is a data frame. I do know it's a data frame because it's read as a CSV. And is one of the reasons why I also want to make sure that it's as a data frame is because sometimes you know, you might have put in a file that sometimes, you know, things just fail. So I just want to make sure that I convert that into a data frame. So just to be safe, I'm going to do that. But that's where all of this is coming from. At the very least. Now, I can do the same thing here, and in fact, it's not, again, I want to repeat that this is not necessary, because we do know that this is a data frame, but it's always sometimes good practice to make sure that we just specify those conditions, because things fail sometimes, as it always does in programming. So what this is going to return is going to basically return the 4 columns on our data set, which we can take a look at by just clicking on this. Well, in fact, we can't take a look at it now because we're running the application. But if we were to look at the application, we have 4 different columns here that are numeric, and then we have species, which is the last that is categorical. So what that piece of code is going to return these 4 columns. And we're going to use this basically to take the row name, to the column names, and use those as our selection criteria for the X and the Y. Okay, so really that's the reason why we're doing this. And we can do the same thing by looking at species here. And what we're going to do now is we're going to say data, right, like that. And again, I'm just going to, for making sure that this is a data frame, this is probably the last time I'm going to do it. In the next cases, I'm just going to call the data. And what I want is all the rows, and then I want this species column. Okay. And out of this, because this is going to give me 150 observations, I want the unique versions of those. So it's going to reduce this to 3. And then I want to make sure that I convert this to a vector, because we need to pass a vector as the input to the select item that we'll do after this. Okay, now that we have that, we can go ahead and do our sidebar menu. Okay, and remember we used the sidebar menu before, and what this does is just it contain multiple menu items. In this case, we're going to have 2 of them. Let's start with the first one. So the first menu item, again, remember that the menu item takes a text argument, and this is, we're going to call this correlation filters. Okay, and then the second argument it takes is the icon, as you can see, and in this case, I don't really have a good correlation icon, no ID, so I'm just going to use the TH, and we can change that later. And then now we're going to have our first actual widget, and in this case it's going to be a select input. And this is going to be for the x-axis. So the input ID for this is going to be the x value, comma, and then we want the label of this to be select x metric, like so. Maybe put a column there, and then comma, and then what I need for the choices of this is the names of the numeric data frame that we created here. Okay, so we could just call names of the numeric data frame. And in fact, the other thing that I need here is a selected, and I'm going to select here the first one. So I'm going to automatically, it's going to pick the first numeric name. Okay, so that's going to close this select input, and then I need to do the same thing for the y. Now, okay, I'm just going to do it for muscle memory in case you're doing this for the first time, but you could just copy this, and all you need to change is really this ID here. But for muscle memory, if this is your first time doing, let's just do it. And then this is going to be y value, comma, and then I need the label. In this case, I want to select y metric, like so, and then add a comma, and then again the choices are pretty much going to be the same because we're looking at only the numeric data frame in this case, and what we want is the numeric data frame. And the only difference we're going to make here is that the selected needs to be different, because if the selected is the same as if the selected is the same for x and for y, then you're just going to have a straight line, and that doesn't at all scream like this is an intelligent app, right? We want to make sure we have two different variables here. And let's maybe add, I'm trying to see, is that necessary? Let's say we wanted to visualize this by species, right? Well, we can add that. If for now, let's leave this as is. We can definitely add that, but let's leave it as is. So let's see what this closes. This closes the menu item, so I'm just going to bring it up here. So this is our first menu item. In fact, let's maybe make sure that we can render this and that it works well. So again, we have created an output ID, so we're going to take this ID correlation filters, copy that, and we see we're rendering menu here, which means, as we have done with every render, right, we've rendered UI here, and usually we have to accompany this with UI output. We have rendered data table here. We had to accompany this with data table output. So we're now rendering menu. We have to accompany this with menu output. So let's go ahead to this sidebar, and we had sidebar menu as the first container. Now after that, we're going to have sidebar menu output, like so, and in this case we paste the ID that we have. Okay, so now let's go ahead and reload our application and open this in browser as we have done. And if we now upload a CSV, which in this case, let's see, it's RShiny, and there we go. Now we have a correlation filter, right? And it has our X metric and our Y metric, and they've been selected such that it takes the first and the second. Okay. What I did want to add before was to add species, so we could have all the species as well. So let's do that. Let's do that now. If we go back here to select input, in fact, what we need for species is checkbox group input, like so. So now that we have the checkbox, let's see. The first thing we're always going to do is the input ID, and in this case is, let's call it core species, because we're going to have to do the same thing with species on on the distribution filters, and then what we need is a label, and the label for this will be species, and then what we need is the choices, and in this case we have just, well, we're going to use the species that we did here, right? That's all we need, really. And this should close this out. That should also close it out. So our first menu item is officially complete. And if you reload this again, open this in browser, right? We upload our CSV as we have done. You'll see that we have now the ability to select this. So what we want with our correlation plot is that we can select these, and then they'll populate our correlation plot here, our scatter plot here, as we need it. So let's go ahead and work on that. Right, so in order to do that, we in fact need to generate some plots. So here we're going to generate scatter plot. Well, let's just call them correlation plots. Both of them. So we're going to have a heat map and a heat map, a correlation heat map, and a scatter plot. Now, before we do this, in case you're new to, and I'm going to stop this application by going to the terminal. In case you're new to R and R programming language, in order to render plots, I am not going to be using the base plotting package. I'm going to be using ggplot and ggli as well. So if you don't have those, the way to install those is what we have done before. And in this case, I'm just going to install it from the command line. So install packages, I'm going to create a vector here, right? And this vector is going to carry the following. We have ggplot2, comma, and we're going to have ggli. I think those are the two that we need. So let's run that. And okay, so that's actually in caps. So it's not GG small caps, uppercase for the first two letters. So I'm going to go use the up command because I've already installed ggplot. As you've seen here, right? It's installing here and it's downloaded. So just make sure that we have capital G's on there. And now it is installed. So once we have that done, just go up here and we're going to add those packages. And so in this case, we need ggplot2, and then we also need ggli, like that. Okay. Once we have those, what we now need to do is to come down here to where we're going to build our plots, basically, and see what we can do. So the first thing we want to do is build our scatter plot. So I'm going to put the output again, right? This is going to be rendered, so output, and then I'm going to call this scatter plot as the ID. And this is, as you guess it, render as a plot. And again, in there, we use the curly brackets. And let's see. Now that we have the curly brackets, one thing we can do is we can say, we can generate a plotting frame, which is essentially just looking at, well, in this case, we would actually need something else. So this is why I didn't want to put this group check inbox in the first place, because now we need to use another programming, well, another package that will allow us to basically filter for these species as we see fit, because we want to have a situation where when we filter for one species, then we take the X and the Y value of that species and just render that in a scatter plot. And this is currently not possible here. We have to use something, we have to use a different package. So let's just install it. And that package is dplyr. I already have it, but I'm going to show you how to install it. So just install it like so, and we have to call it up here again. And in this case, it's going to be dplyr. Okay. Now that we have that, so what we're going to need is to need a plotting. We're going to create a temporary plotting df. In fact, let's just call it plotting df data frame, and this is going to be as well. In fact, I promised I was going to use this, so I'm just going to use data like that. And we need to make sure that we're filtering right for the right species. So we're going to here filter. Well, that's not it. Filter for species, and we want to make sure that the species are in what we selected. And notice that we have here checkbox that we generated that has the ID of that. So what we need to do here is to say as.vector of the input, the input, and then the input of this coral species. Copy. So once we have this, and in fact, you don't even need to have this equal sign. You can just, by dplyr, you could just pipe this to a ggplot, but I'm going to do this because it systematically helps me to troubleshoot things as I move along. So once I have that, this is basically going to return a plotting df, which has been filtered by the number of species. And then what we can do is we can say now ggplot. Okay, and we're going to say that our data here is the plotting df, right? And then we need to have our mapping, or some people just immediately go to aesthetics, but mapping is the keyword that takes the aesthetics, and we're going to use aesthetic strings. And the reason we do that is because we're using the inputs from our select inputs here. Otherwise, you just use aesthetics. And so x equals to input, in this case input x value, right? What we just generated here, x value. We do the same thing for y. Input y value, and then the color. In this case, we're just going to call the keyword species. All right, so that generates the contents we need for our plot. But what kind of plot is it? We want to make sure that this is a geom point for scatter plot. So this should effectively work. Well, so let's just test it. Let's just test it, and in order to render this, we need to take the ID we've generated, come down to the tab panel where we have correlation plot, and again, because this is render plot, as you would guess it, it's plot output as the function that we need to pass that ID that we've just copied. In this case, it's scatter plot. So we should have everything that we need. Now let's go ahead and run this application. See if we have any errors. We shouldn't, but browse, get the iris CSV. Okay, we have a canvas where we can plot things, and the reason we probably don't have this is because we haven't selected any species. But if we selected the first species, then we see that we have the visualization come up. If we select the second species, we see and it's colored by the species, and then if we select the third species, we see that. And we can also change the x and the y, right? If we change both the petal length, maybe sepal length as well, we see it changing. So we have now generated, the application with the ability to basically do a little bit of filtering here and see a reactive plot, change like so. And we didn't need to convert the data object to a data frame every single time. So that is convenient. Now, the other thing we need to add to finish up this page is we need to add the heat map, correlation heat map. And this is the same thing, it's output ID, and I'm going to call this correlation heat map. And again, this is a render plot. Oh, nope, that's not it. Let's actually just make sure that we can, yeah, there we go. I don't want to actually type it, because good thing about using RStudio is it provides the right function as an option. So for correlation plot, we don't really need to worry about filtering anything. What we do need to take into account is, in this case, just looking at the numeric data frame, right? So we need only the numeric data frame, which we did before. So this is what I'm trying to say. We need to take this numeric data frame here, this line of code, and we could just paste it here. And then all we need now is we could call GGs. I think it's pairs. I think we can use GG pairs. And now numeric df, and all we need is the mapping, and the mapping will just take the aesthetics, and in this case the aesthetics will just be the color. And here the color, let's make it maybe blue. We might need to, well, in fact, let's not use pairs. What we need to use is the GG core. Okay, and in this case we're going to use the numeric data frame itself, and then we're still gonna, we don't need to use any mapping. We can just say, let's take the palette for this, would be RD BU for red and blue, and then we want the label to be true. Okay, and we can now take this ID, correlation heat map, copy it, and exactly where we had the correlation scatter plot, just after that, we're going to add plot output, and now we're basically placing two plots in the same plane. So let's go ahead and refresh this. We might get an error here, but if everything else worked well, we shouldn't. So, okay, well, that's even without selection, all right? So it's giving us all the correlation without the selection, as you'd expect. Some of these things are correlated 1-to-1, but as with our species, then we can do that. Now, you could also basically select, you could change this based on the selection of the species, and actually it would make sense to do that in some instances, but we're not going to worry about that. I've already shown you the example of selecting up here. You could basically recreate some of the dplyr things on there. So what is left now is to take care of the distribution plots, and we have the correlation plots here. The raw data has already been configured, so we need to work on this, and that's what we're going to do in our next and our last section. Okay, all right, let's call it for now.